Assalamualaikum warahmatullahi wabarakatuh. Topik 3.1 Hydrodynamic Fluid Flow for week 12 and week 13. Okay, this is a list of reference that you might refer for this topic. For today, we want to go through the subtopic 8 Applications of Momentum Equation in Fluid Flow. Learning outcome is correlate the principle of conservation of momentum and momentum equation on stationary object. So and then we need to solve problem related to jet impact on stationary flat, and another one is for curved object. Then we need to apply the momentum equation and propose the suitable solution for that problems. Okay, applications of momentum equation in fluid flow. Basically, in fluid mechanics, the analysis of motion is performed by using Newton's laws of motion. Okay, what is the Newton law of motion? It is the second law where the rate of change of momentum is equal to resultant force acting on the body and takes place in the directions of the force. Okay, it must be change of momentum is equals to resultant force. Okay, let's see on the momentum equation. So we consider a control volume in the figure. So we have a pipe that have different area or enlargement pipe from small pipe to bigger pipe, and we are assuming the fluid flow is a steady non-uniform flow. Okay, for mass entering stream tube is actually equals to mass leaving stream tube. So the formula is volume times the density. So here density and also volume, area times velocity times change of time. dt is change of time. Okay, so here we have area, velocity and also pressure. Okay, this one is pressure. And then same also for leaving, volume times density. Okay, then for momentum of fluid entering stream tube is also equals to momentum of fluid leaving the stream tube. Okay, we calculate momentum as mass times velocity. So we have bigger M times the V for momentum calculation. So M mass is density times area times velocity times change of time. Okay, same also for fluid leaving the stream tube. Then apply Newton's second law, where Newton's second law states that force is equals to rate of change of momentum. So for the word rate here, we need to consider the time. So we divide by change of time. So the change of momentum divided by time, it become rate of change of momentum. After that, we apply continuity equation where the flow entering the tube is equals to flow leaving the tube. So we get Q, and we assume that the density is constant because inside the tube we have one type of fluid. So when it's used one type of fluid means the density is same. So we get the density. So then we have the derived formula for momentum equation is force equals to rate of change of momentum, or can be written as density times Q is flow rate times change of velocity. Means velocity 2, velocity leaving the tube minus velocity entering the tube. Or density times Q can be write as capital M for momentum. So momentum times change of velocity, it is can be get as force, or it can be considered as rate of change of momentum. So we assume the inlet and outlet velocity are the same directions, so we consider as one dimensional system. Okay, just now we already know the formula for force. Force equals to density times flow rate times change of velocity. So actually this force is made up of these three components of F. So F1 is equals to Fr, which is force exerted in the given direction on the fluid by any solid by touching the control volume. Okay, and then F2 is force that due to gravity. Okay, this one is considered zero when it is horizontal. Bila ada mention the word horizontal plane, tak ada gravity lah, it considered as zero. Okay, then F3 is force exerted in the given direction by fluid pressure outside the control volume. Okay, so this is as Fp that relate to the pressure. Okay, so we can consider as F total is equals to F1 plus F2 plus F3. Okay, this is the formula here. Density times flow rate, velocity out minus velocity in. Okay, so the force exerted by the fluid on the solid body, mesti touching solid body ataupun boundary. The control volume is equal and opposite of F total. Okay, so R is equals to negative F total. Okay, then we need to see on the applications of momentum equation. This is how we need to solve problems of civil engineering that related to the momentum equation. So we have the impact on jet. Okay, ada tiga condition which is a stationary vertical plane. Vertical plane bila straight, solid boundary dia straight. We have impact jack on the inclined plane. Okay, this one biasanya kita consider as wiper. Wiper crater tu it is inclined plane. And then we also have the curve on curve surface. This is the steps in analysis and solve problem related to momentum equation. So first we need to draw a control volume, and then we need to decide on the coordinate axis system. So axis lah x, y, z, and then we have to calculate the total force. Tadi total force is F total equals to F1 plus F2 plus F3, and then we need to times with the change of velocity, and then we have to calculate the pressure force, calculate the body force, and lastly the resultant force is Ft negative Ft equals to R. Okay, resultant force is from the F total. Okay, let's discuss on the example. So we have water flow at a constant rate in a tapering pipe. Okay, constant rate tu maksud dia Q lah. So it means Q1 must be Q equals to Q2. Q entering is equals to Q leaving the pipe. And then the pipe is converges ataupun semakin mengecil, constriction from 50 cm to diameter that we don't know. We don't know the diameter for here, second diameter. And then if the water accelerate pecutan from initial velocity of 2 to final velocity of 4.5. So we know the V2 and the V1. Determine the flow rate and the accelerating force. So we know that Q1 equals to Q2. So the formula of Q, still remember, Q equals to area times velocity. So this is how we calculate the area. Area is pi d squared over 4. So times the velocity of 2 for entering. So we get the Q1 is 0.4 and Q2 also 0.4 meter cube per second. And then we need to calculate the accelerating force. This is the force. So the formula for force just now you already know, which is density times flow rate times change of velocity. So we get the accelerating force about 1000 Newton. Okay, then next subtopic, which is 3.1.8.1, which is momentum equation on for 2D flow. So this is the XY axis that we need to know. And then this is flow of water. We have angle and angle 1 and angle 2. So we consider 2D flow where velocity 1 makes a certain angle, which is with x-axis. So untuk V1 kita consider dia as x-axis. Okay. And then for V2 makes an angle of 2, and the momentum and force can be resolved into component in x and y direction. So for entering, we resolve to x direction. Okay, for V2 we consider for y direction. Okay, so we resolve into both component x and y. Okay, then this is how we resolve for x direction and also y direction. We need to solve it one by one. So we see for fx first. So fx is rate of change of momentum for fluid in x direction, ataupun it can be calculated as rate of change of mass, capital M just now, times the velocity in x direction. So for fx, you need to see this one only. Okay, so mass times v2x minus v1x. So it is considered as cos, sebab we resolve from flow dia macam ni, tapi kita nak resolve kepada fx. So kita guna teorem Pythagoras. So ke bawah maksud dia cos. So this line is cos. So that's why this is cos. Okay, so we minus V1 cos angle. So the M tadi can be changed as density times flow rate. So for this one, we can cancel the cos sebab sama. So we get density Q equals to velocity 2x minus velocity 1x. Okay, so untuk kat sini, velocity kat sini, dia akan jadi velocity 2 is 0. Sebab kita ada velocity 1. So, dia pergi kat sini. So, kat sini ada velocity 2. So, here velocity of 2x ialah 0. Okay, boleh sebab dia flow dia daripada sini kepada sini. So kita dapat velocity of 2x is 0. Velocity of 1x, basically it is given. Okay, settles for x directions. And then we see for y direction. Y kita pandang yang atas ni. Okay, this is for y. Okay, then sama juga force dia equals to rate of change of momentums for y direction, or rate of change of mass times velocity. So rate of change of mass times velocity. So we resolve to y. So here is sin. Okay, this is sin ataupun sin. Yang bawah cos. Okay, so same V2 minus V1 following the formula just now. So here from this one we have this point, right? So dia start daripada point yang bawah ni. So V1y is 0. Okay, sebab dia start daripada point sini, point yang 0 ke atas. So V1y is 0. Here is 0. V1y is 0. So kat sini ada V2y. Okay, and then only we can calculate the resultant force. Okay, this one you already learned for chapter inclined plane and curved plane. Resultant force is Fx square plus Fy square. Previously you learned on curved surface, right? So curved surface is Fh square plus Fv square. Okay, but this one we change to Fx and Fy. And then we know the locations. So angle is equal to antitangent Fy divided by Fx. Okay, then for next subtopic 3.1.8.2, forces for inclined plane. So the velocity, the water jet is from here. So this is how we calculate. Okay, this is the applications of Viper crater. So Viper crater dia akan sangat sikit with angle. So we have V1, V2 and V3. So actually when we calculate for easier analysis, we need to rotate the inclined plane into vertical plane. So we write Fx directions, Yx directions. So this one. Okay, next step we need to write down all the equations and formula that related to this question. So we need to write the Bernoulli equation, but we need to write in terms of 3 velocity, because we have 3 velocity just now. We have V1, V2 and V3. So Bernoulli equation state that the V1 it is equal to each other. So and then we need to negligible the height difference and also the atmospheric pressure, sebab height ni sebab dia horizontal plane. Dia tak ada elevation, not have any elevation. So we consider the V is 1V, constant V. And then we have the continuity equation. We have also 3 flow rate, which is Q1 equals to Q2 plus Q3. Okay, and then we need to substitute the formula for Q equals to AV. So we have AV1, AV2 plus AV3. Okay, and then for Q1 we have A1V, because we already consider the V is constant, so just write the V. For Q2 the same, A2 times the V. Okay, for Q3 the difference is on the area, so we need to minus area 1 minus area 2. Okay, then we need to find this charge in all directions. So we solve for y directions. So V2y equals to V2 and V3y equals to negative V3. Why it is negative? Because V3 just now is to below, right? So when it is in different directions, so it is negative. Okay, sebab dia ke bawah, so negative. Okay, for V1y, this one, Just now we consider it as y directions. So V1 is like this. So we resolve to y directions. Here y directions. So it is sin. Okay. Bila x direction, it is cos. So we resolve to y directions. It is V1 sin angle. Okay, so we consider V1y equals to 0. And then the formula for force is density times flow rate Q, V out minus V in. Okay, so we have density. The Q is Q2 plus the Q3. So we need to minus the Q1. Okay. Q1 is the in. The out is Q2 and also Q3. Okay, then we make it into long mathematical equation. So we can consider is A2 minus A3 minus A1 sin Q. Okay, why the equation become like this? Because just now we already consider the V is same. So V1 just now equals to V2 equals to V3. So equals to V, right? So that's why we get A2 minus A3 minus A1 sin theta. Okay, and then we need to find, we already considered the V is still the same. So we can have A equals to V. Okay, so the formula is Q equals to AV. So V is considered the same. So we get Q equals to A. So we have A1. We bring to here. So it become positive. A1 equals to A2 plus A3. Okay, then we consider it as 0. So we have A1, we have A2 minus A3 minus A1, right tadi? This equation bring it to here. So we write down back, but we need to change the A1 into this. Okay, this is actually A1. Okay, then from this equation we can simplify as this. Okay, and then we already consider that Q equals to A, so the A can be directly changed to the Q. So Q2 A3 jadi Q3. So for this one we just copy from above. Okay, then this one, where we get this? This is from the previous equation. A1 equals to A2 plus A3. Okay, so this one we get A1 equals to A2 plus A3. Okay, then we substitute, we simplify, we get this one. Okay, this is the final that we get. Okay, then let's go through the example with the number. So same as the previous equation, the previous question, but now we include the number. So we have a hose and a nozzle discharge a horizontal jet. So this is horizontal jet, and then given the diameter of the nozzle is 25 mm, so need to convert to meter, and the discharge is 0.025. So this is Q out. And then we need to calculate the force necessary to hold the plate. So we hold here. Okay, so this is R. Okay, then so first thing first, we find the area because we already know the diameter of the nozzle. So we use pi d squared over 4. So this is the area of the nozzle. And then we calculate the V1x because we already have Q equals to AV. So when we find V is equals to Q divided by area. So 0.025 is the Q divided by area. We get this one as the speed or velocity. Okay, why V2x is 0? Because it moves from here to here. At this point, the V is 0. So this one is V2. Okay, because we already have V1 from earlier. So V2x is 0. Then we can calculate the Rx. Rx is the density times the velocity V, right? And also, oh no, not density times the Q. This is the Q, 0.025 is the Q, then only the V. So Q and the V times the V. So you get the Rx 1.273. Unit of force is Newton. Okay, next we want to go through the examples for curved surface. So we have a jet of water flowing freely in the atmosphere. So the angles is 90 degree and the diameter of pipe given 20 mm, need to change to or convert to meter. And then we have the velocity v1 and find the force required to hold the vane. Okay, so we need to find the force required to hold the vane. So this one is v1x. So here we have v2x. So v2x is 0. Okay, and then we have v1y is 0. Here we have v2y. Okay, this is how we solve the problem. So we need to write the axis system. So this one is mean by the step that we need to write the axis system. So we have the R1 resolve to y direction. So we have R and then we have the Rx for x directions. So we can determine the area first because we already know the diameter of the pipe. So we use the formula pi d squared over 4. And when we get the area, of course, we can calculate the Q. Using the formula Q equals to area times the V. Velocity just now is 5. Okay, then we need to solve one by one. This is for x direction and this is for y direction. So for x direction, I already mentioned that v2x is 0. So f1x equals to negative rx because it is in different directions. So we have negative here. So we substitute into the formula of density times q times v. Okay, times change of v. So actually here is change of v. It is v2x minus v1x. So here is actually 0 minus 5. So we get negative here. That's why we can cancel the negative. So we get Rx is positive 7.855. Okay, then we solve for y directions. Y direction, just now I already mentioned, we start from here. V to y is 0. V1y, sorry, it is V1y is 0. So we have here V2y. So here we have also negative Ry because it is in opposite direction. So we use the same formula, density times Q times change of V. So the change of V here is 5 minus 0. So you also get 7.855. Then only we can calculate the resultant force, Fr. Fr is Fx square plus Fy square. Then square root, we get 11.11 Newton. And then we can calculate the angle, the direction. Dekat mana resultant force angle, dekat mana kat sini angle. So antitangent of Fy over Fx, so you get angle is 45 degree. Okay, then let's go through another example. So we have a jet water with diameter of 50 millimeter, need to convert to meter. And then we have the velocity is 18 meter per second. Strike a flat plane inclined angle of 20 degree. So this one we already know it is inclined. So we need to consider that the water jet hit the inclined plane. So you need to imagine a little bit on the question. So determine the normal force exerted on the plane when the plane is stationary. Okay, this is how we draw the question. So we have V1, V2 and V3. So we need to rotate it to make easy analysis. So we rotate this one as vertical plane, not inclined plane. Okay, then we need to consider condition for plate to be stationary. So F1y is 0. So maksudnya dia tak bergerak. Biasanya Viper dia akan bergerak. So we consider it as stationary. So bila stationary, force dia akan jadi 0. So we have V1x. Y it is sine because we resolve to x direction. So this is the water jet tadi. So we resolve to x. Okay, this is x. So kita resolve ke atas, so dia akan jadi sin. Kalau kita resolve ke bawah, dia akan jadi cos. Okay, so V1 sin 25 degree. The V is given 7.607 meter per second. And then we need to find the force for x direction. So we have out minus in. Okay, so we have this one out minus in. So out dia ada 2x plus 3x sebab dia ada dua direction kan. Dia resolve ke atas dan ke bawah. So ada 2x and 2x and 3x. And then we need to minus the q in. This is q in. Q out minus q in. So after we simplify the equation, we get this one. F1x equals to negative density times flow rate times V. Okay, so we substitute the value. Density is 1000. Okay, the Q is area pi d squared over 4 times the velocity 18. So you get the force is negative 268.527. Okay, and then the question asks you for the Rx. So this is we consider f negative f1x equals to r1x. So we get the Rx in positive value. Okay, next this one I need you to try by yourself. So how we calculate this? We have the diameter of water jet, so you can convert it to meter, and then the velocity is given 35. Okay, so we need to determine the force R, which is needed to prevent the plate from moving horizontally due to the water stream if the nozzle is replaced with a smaller diameter, while assuming the flow rate to remain the same. How would this affect the force and velocity? Okay, this one you need to answer in sentence when the size is different. Okay, so we need to determine the R. R is negative F equals to R. Okay, this one also for curved surface. I need you to try by yourself. So the angle is given by 30 degree for the curved plate, and the velocity is given 30 meter per second for V1, and V2 is 10 meter per second. Okay, so the Q is given by kg, so you need to change to meter. Okay, this is the Q, this charge. So we need to find the angle and the magnitude and directions, means you need to find the resultant force Fr, okay, which is Fx square plus Fy square root, and also the angles is anti-tangent Fy over Fx. Okay, so we have here V1y, we have here V1x, so here we have V2x kat sini, V2x and V1y kat sini, V2y. Okay, so V1y is 0, V2x is 0. Okay, try this first and we discuss the answer later. Okay, this one also we need to try because this is the curved surface. So the flow rate is given Q and the velocity is 8 meter per second. Deflect horizontally. Okay, so we need to determine the resultant force on the chute and the direction in which it is acts. Sama lah yang ni pun sama, dia nak resultant force and also the angle. Okay, and then this one also you need to try yourself. Okay, this is the window cleaner. The diameter is same 45 degrees Celsius. The velocity is 8 meter per second. 8 meter per second, and then hit the glass window 1/3 of the flow split and goes upward while the remaining goes downward. So dia dah bagi tahu 1/3 daripada flow Q ke atas, ke bawah 2/3 daripada flow 2/3 Q. Okay, and then we need to evaluate whether the jet is strong enough to break the glass if the glass can withstand a force up to 100 Newton. Okay, we need to determine whether the jet can break the glass or not. by determining the force. Okay, thank you. End of topic 3.1.